Hi, I'm Guo Cheng Guang, 12 years old, secondary 1 from NS High School. Over here, we're still continuing with our organic chemistry. So in our first part over here is the classification of organic compounds. So in the last lesson we had this classification whereas we grouped them into alkane and alkene into these two different parts. So this is what we had last time. But let's just take the first alkane that we have. Okay, so the first alkane, that is when this N is equal to 1, we have our methane. So right now in this lesson, we're just going to use this part. So in methane, if we want to actually draw out what it actually looks like, well, at least is what we think it looks like, we first have to think about the relationships between like C and H, the relationships between each hydrogen. Okay, so first of all, between C and H, there's a bond between them. Well, these bonds is just these protons attracting the electrons of the other atom. And from the other atom, the same thing happens. So it's just between the proton and electron attracting. So between H, that means what we'll have at this N over here will probably just be left with the proton. So when we're left with that proton over there, when they get close to each other, proton, they will repel each other. So that means between each hydrogen atom, they will be repelling. So that means from this part, we'll need to spread out each hydrogen atom as apart from each other as possible. But still at the same time, since each of these hydrogen atoms, they are the same, so they will have the same force received from the carbon and same force received from each other hydrogen. So that means the distance between each hydrogen atom will be the same from that part over here. So all those distances will be the same. So let's just say we're using equilateral triangles. So equilateral triangles, that means we have every 3 of them can form one. Then we will have 4 faces. Well, 4 faces, equilateral triangle. That's a triangular based pyramid. You can just simply call it a pyramid. Or if you want to call it a tetrahedron. So all those ways of calling this type of shape is possible. For hydrogens first. So this is the part that is in front. Then after that, for the part behind, since we're showing that it is behind, we're going to use dotted lines for that part. Like this. Then after that, we'll try to find where could the carbon be, because in this part we're drawing for a methane and we've already have the 4 hydrogens, so the only thing left will be for our carbon. I think it should be around somewhere here. Or a little bit lower. Okay, so it may be around that part here. So from this part, then we're going to join them again. Okay, so you have these parts over here now. After that, I'm just going to change some parts so that I'll mark out the carbon and the hydrogens. So at this part over here is your carbon or carbon at this part. And after that, at this corner here is your hydrogen. Okay, so that's what you have here. 1 carbon and 4 hydrogens from this part. So at this part, we have known of how this methane would probably look like. But next, when you look at this part, you may suddenly have questions like, between this bond and this bond, what is the angle there? Between this bond and this bond, what's the angle? Well, first of all, let me just tell you first, if you want to find that angle for each and every one of them, you only need to find for 1 angle. Now, how is that possible from here? Let me just tell you. So each of these faces that we're using are equilateral triangles. So we're using equilateral triangles, that means all of them will be very symmetrical. So since all of them are symmetrical, that means this, if you reflect it to the other side, the angles are still the same. So since you had same angles, that means you keep reflecting, then each of these angles will be the same. Okay, so that's what you can have from this part here. Alright. So that means we just need to find for 1 angle. But let's say, for example, we want to find for this. How can we find it? Well, from this part, we may need to draw auxiliary lines. Well, I'm just going to show you first what it will be. So this auxiliary line that we will have here, it is over here. But then you might think, how is it possible? So let me show you here now. This hydrogen, it wants the carbon to go up, since you have the bond between them. So it wants the carbon to go up, but the carbon didn't. Now, why did carbon not go up? Well, you can say that it is being pulled down by these 3 hydrogens. Well, since all of these 4 bonds, they're actually all forces, showing where are these hydrogen pulling the carbon. Well, you can say it like that. Or you can say this is pulling it this way, those 3 are pulling it that way. Then you have to draw it in that direction. Then after that, you have different ways of saying where does it go. So from here, I'm just going to use, this is pulling it up, but these 3 hydrogens are pulling the carbon down. So from this part, let's just let this force we're using the F, since we like to use F for the forces. So here is another F. But then we want to find this downward force, or in this component, the force used in this component. So from this part, you can just use so let's just say here is that F is pulling down in this direction. Like this is the F. Then after that, you separated it into 2 components. Here you call it F1, and here you call it F2. But at this part, you need to know one of these angles, or you just let one of these angles. So if you let this angle be theta, here will be theta from this part. Okay, that's what you have first. Then you try to find F1. So F1 from this part, if you close this up, there is a right angle triangle that you get over there. And since you get a right angle triangle, let me just tell you that you're going to use trigonometry at this part. So we're actually combining mathematics and chemistry together, like finding their angles. So to find this angle, well, that means you have to use cosine since it's adjacent to this angle. So that means you have F. But wait, let's just take that value only. So let's just only take that value from this part. So F1, this one, the value will still be F1. Here the value is just F. Then after that, times cosine theta from this part. So that will be what your F1 will be. So let's say if it is on here, here is your F1. So then that means here is actually F cosine theta. But beware, it is 3 of these same forces. So that means you need 3 F cosine theta. Then this part is equal to, it's the same as going up. Since this is not moving, this curve is not moving, that means, well, you can describe it as balanced. So then you get it equals to F. Okay, so you got this equal to F cosine theta. Well, you just divide that. So theta from this part is inverse cosine 1 over 3. Well, from this part, you cannot directly think about how you could calculate that. So you need to use calculator for this, since you cannot directly find what is it. Okay, so it seems like from this part, what it gives will be around 70.5 degrees. But is this the angle that we're finding? No, this is not the angle that we are finding. This is not the angle that we're finding, okay? Why? Well, this is only the angle at this part. But beware, this is to this line. It's not like go in front, then you just times. So from this part, but what you do know is that this is on a straight line. This is a straight line. So that means the angle of these parts together is 180 degrees. So to find this angle that you want, you just have to use that. Well, for example, if you call it like alpha, so angle alpha, this part will be (109.5 degrees). So that will be the angle to between each of these bonds of methane. Well, you can say as a molecule, you can say as a methane compound here. So that is the angle. So it's actually pretty weird sometimes, you may think it is a very regular number, but then you get this thing. And if you write everything out, well, actually, that is a very weird number here. So from this part, so let me just tell you again how you can get this structure first, then how you calculate it. So just a short summary from that part. So no matter what compound or what molecule you get, first of all, you think about the relationships between each of these types of molecules, whether they are together. So together, for example, carbon and hydrogen, the hydrogen will want to pull the carbon closer to it. Well, each of these hydrogen want to. But then after that, each of these hydrogen, they repel each other. So that's just an example for this methane. That's their interactions with each other. Then after you think of, so how many hydrogens? Well, you have 4 here in total. So 4, then it'll definitely be on this 3D from here. Well, that's why from here you look like as if it is 90 degrees each, but in reality it is 109.5 degrees. So just telling you that on 2D it doesn't tell you what angle it is, how long is this, but when drawing to 3D and you actually calculate it, well, you can find what the actual value of these angles are. Well, this is just a very simple representation. So then from these parts, we're just using what we have learned before, including trigonometry. That was just simple calculations, then we're done. So I hope that you can understand this so far. So if you like our videos, don't forget to subscribe to our channel. We'll see you in the next lesson. Thank you for your watching.